yellow cover on it. So, and we're going to talk about all of those things. Mode is the one that occurs most often. It's where data tends to cluster around. That's basically what measures of central tendencies. That's what they are trying to do. When you're finding the mean, median, and the mode, you're trying to see, okay, if I took all of my data points, where would I see the most? Where would I see the data gathering around? Okay, that's what MCTs are trying to do. We're going to talk about dispersion, and otherwise known as range, right? Dispersion, it is very much related to the range. How spread out is the data, right? So dispersion, think of spread out, okay? How spread out is it? How does the data deviate from the mean? How is it different from the mean? So we're going to talk about that as well. And at the core, of course, we have data, which could be, right, heights, test scores, IQ scores, number of items that a store is selling. Amazon, oh my goodness, if you went into their stats department, you probably get big bucks because they want to know where are we selling most, what are we doing, like what do we need to do to sell more, right? What time of the day do most people buy stuff? What day of the week? All of those things, data, if you can analyze it, it will tell you that. So data is at the center, right? That's the center, what everything revolves around data, right? So everything revolves around that. And so the things that are around it and the other boxes is just related to it. We're going to talk about standard deviation. That's going to be a very, very, very important topic. So remember standard deviation. I will tell you what the symbol is. It comes back later. It's basically like a 0 with a little tail on the top like that. It's sigma. It's lowercase sigma. Okay, it's a 0 with a little tail at the top. Measures how spread out, right? That's in a nutshell what the standard deviation tells us. It's a number. We'll calculate that. Tells us how much data deviates from the mean. So in a sense, these two here are related. But we first start talking just about this, what we observe, and then we realize that this can be calculated. Okay? Then we're going to talk about visual representations. That's like how can we like organize this as a graph so we can like visually see where our data is and what it is doing. Okay? And then this is like the grand finale is normal distribution. That's where we're going to spend most of our time towards the back half of this course, of this unit, I should say. And so normal distribution, I want you to think of a bell curve. Have you heard of that term? Remember flatten the curve? Remember when they were talking about that as COVID? That is basically, it comes from statistics. Because if you, let's just draw a straight line like this. In statistics, we're interested in seeing a bell curve. Okay, so right, bell curve. And why is it called a bell curve? Because it looks like a bell. Okay, sometimes it's flat, sometimes it's steep. So normal distribution, think of a bell curve, and in the middle, try to cut it in half as best as you can. In the middle, we have the average. Okay. So remember when the isolation days, right? What was it at the beginning? 14 days or something like that, right? Why did they come up with 14 days? Because they observed that some people, it took less than 14 days till they're completely symptoms free. Some people took longer, but most people were around the 14-day mark. and then they changed it, of course, as they learned more and more about the virus, and they collected data. That was the biggest problem at the beginning, no data. They had no data to go by, right? But then they realized a lot of things. Data drives our decision making. Hospitals use it all the time. Okay? So now let's start with the first part, which is the MCTs. MCTs. Let me just zoom into that. Mean, median, mode. A measure of central tendency is a number around which the data is clustered. So you'll hear me repeat it. Number around which data clusters. In mathematics, there's several different measures of central tendency. The most common is the arithmetic mean. Can you put this is just the same thing as the average? Like, you know it as the average. And the symbol for average is X with a bar on top. When you see that symbol, you know that they're trying to find the average, okay? That's the most common symbol. So let's talk about the mean. Let me just fold this once because it's bugging me. The mean is the first one. So we are not going to spend a whole lot of time doing this by hand. We're going to use our calculator because you're going to get like 20, 30, 40, 50 points thrown at you. We can't do it by hand. It takes way too long, and I'm not interested in doing that in this course. That's not the goal. The arithmetic mean is denoted by the symbol, right? X bar. It is found by adding all the values and then dividing it, the sum, by the number of values in the set. Make sure you include units. So if we're talking heights, then it should have, centimeters, inches, feet, whatever. And this is the formula. This is the official. It may look a little scary, but don't fear it. The average is found by, this is a capital sigma letter, which is a symbol for adding everything up. If you add up all the values, which we call x, you would then divide that answer by n. Okay. So the top is the sum of all data, right? And the n represents the number of data. So that's just the official then next we have the median. Median is a set of numbers. Median of a set of number is the middle value of the data set. Okay, middle value of the data set. It is most easily found when the numbers are listed in ascending or descending order. Okay, watch this. The median indicates that half of the values in that set will be below and half of the values will be above. Okay, watch this. The stars here, if there's an even number of values in the data set, the median is the average or the mean of the two middle numbers. Make sure you include units. I put that down every time because students tend to forget. So let's give you, I'm going to give you an easy example here. Let's say this is already arranged: 2, 3, 5, 11, and 16. It's arranged, right? You agree with me? You have to say yes. I arranged it for you. The median here would be easily recognizable. That is your median. Okay. And see, half of the values are below, half of the values are above. So that's easy. But what if, let's do the exact same set. What if I add a value to that set? This is a new set, 2, 3, 5, 11, 16, 21. How many values do we have? 6, right? It's an even number of values. So you do not have a single number. If you picked 11, you would have 3 and 2. If you picked 5, you had 2 and 3, right? Above and below. So here you need to take these two and find the average. So the median, I'm not going to spend a whole lot of time on this because our calculator is going to do the rest for us. 5 plus 11 is 16 over 2. So my median is 8. 8 is the value that would cut this half and half. Okay. If you listen to the news, quite often they talk about the median income, the median family income for Winnipeg. So that's the income that the government, the city knows. This is the income where half of the people will be making less and half of the people will be making more than that. So the median is something that actually comes up quite often, right? Mode is the number that occurs most often in the list. So number that occurs most often. Make sure you include units, just in case you're forgetting. There are 3 options. You can have 3 things appear. You could have a set with no mode. Okay? No mode is when all the numbers appear the same number of times. So let's say you have 3, 3, 4, 4, 5, 5, 11, 11. So you look at this data set and you look at, oh, maybe 3 is my mode because it shows up 2 times, but so does 4, so does 5, so does 11. They all appear the same number of times. So no mode. Okay. Do not say that the mode is 0, because then you're telling me 0 is the one that shows up most often. Okay. This has no mode. One mode, you can have one mode. That's the one that's the easiest to identify. So let's say you have 2, 2, 3, 3, 5, 5, 5, 6, 9, 14. What would be your mode there? You scan and you see that the 5 is the most popular one. That's the one number that appears the most number of times. So here your mode would be 5 units. Okay. Oh, I should also say that keep them as a like mode will not be a decimal, but the other values could be decimals, and that's fine. You could have a number of modes, right? So this is the case where you could have, right? Let's say you have -3, 0, 1, 1, 1, 7, 12, 13, 13, 13, 17. So let's just say you have a set like that. I arrange it to make it easier for us to see. Our calculators are going to arrange for us. So that's kind of nice. You scan this and you see that 1 shows up 3 times here, and so does the 13. So you have 2 that are definitely standing out. So in this case, there's a tie between them. So the mode here, the mode would be 1 and 13 units separated by a comma. And there could be more. If you had another set of values show up 3 times, then there's a 3-way tie, then all those would be considered modes. However, let me see if you understand here. What if all numbers showed up 3 times? Every single number showed up 3 times. No mode, okay? Because then they're all tied everybody loses kind of thing, right? So then don't put one down, but don't put down 0. Oftentimes like mode 0, right? Like no, it's no mode, or NA, that's fine. Okay, so those are the MCTs. Watch this note. Although the mode is referred to as a measure of central tendency, right? The mode, I'm just going to highlight the mode. It does not necessarily lie towards the center of the list. Mode is one of those that it could be way outside, not where most data points cluster around. The mode is used in different situations than the mean or the median. For example, right, a store owner could use the mode to find out which t-shirt is the most popular, which t-shirt size is the most popular. Okay, so to place your order, you would probably go by the mode. Years and years ago, I used to work at 7-Eleven, night shift, right? So I always had to place the orders for all the sandwiches and the rolls and the wraps and the drinks and blah, right? So as soon as I scanned it, the computer would tell me, right, out of these juice boxes, order most of the whatever, orange or apple or whatever. So that was basically, it was keeping track of the mode over time. Next, range is not an MCT. Watch it. It's not an MCT, but the range, it is calculated by subtracting the smallest and the largest data point. So the range is always like, what's the difference between the largest and the smallest? Okay, it is a measure of dispersion. Okay, dispersion, think of it as how spread out it is, right? How spread out is it, right? Points are. I know I'm bombarding you with a lot of definitions, but it's important for us to have a grasp before we can do the math, okay? Outlier or outliers, its value or values are significantly different from the general trend. Watch this. Outliers cause the mean to either increase, right, or decrease. They also affect the range, okay? What are outliers, right? Like if I always look at it this way, during COVID, a lot of people made no money all of a sudden, right? There were some business owners, I mean, sure, there was help from the government, but either the income went all the way to 0 or significantly decreased. That is an outlier. So if you look at your income, right, 5 grand, 5 grand, 5 grand, 2 grand, 1 grand, right? It's like, whoa, this is very different than the rest. So those would have been considered outliers because it's very different than most of the data points you collect, right? So COVID is basically, by definition, years of outliers, right? That's what happened there. And this is basically the most important topic in this course, standard deviation, for you to understand it, okay? So I will highlight that. And that's the symbol there. And I will also refer to it as SD sometimes in our notes, okay? Just to save time because we use it quite often. It measures the dispersion or variation within data points around the mean. Put simply, I hope this makes it easier, standard deviation is the average distance from the mean of all data points. So if you took all the data points, it will tell you how far away they are from the mean on average. This can be calculated, right? This can be calculated, right? Has the same units as the data we're talking about. I will highlight this too. It may not make sense right now, but it will make sense later. So when you flip through the notes, it will make sense to you. So watch this. I'm trying to summarize this here a little bit before we dive in. A lower standard deviation. Okay, pay close attention to this. What does that mean? Well, we can have standard deviations from two different sets of data points. So when you have one that is lower, a lower standard deviation generally indicates that, right, the range is low. Range is low. If the range is low, right, that means that the difference between the largest and the smallest is becoming smaller. So the data points will be closer to the mean. Data is clustered around the mean. We would also say that data is pretty consistent. That is huge. Okay. There are few or no outliers. The graph will have a steeper curve. So notice this graph compared to the one at the bottom. The bottom is what? Is flat, right? Flatter. Like if you look at the one, you can't see it on the screen right now, but so a low standard deviation, all of this is there. And maybe I would definitely say that this is a good study sheet entry. Just to try to compress it a bit. A higher standard deviation, you have the range that's greater. Data is spread, right? Data is also scattered. You can say the same thing. It's less consistent. And it will be a flatter curve. How about we just do that here? If the SD is greater, right? If it's greater, then this happens. And at the top, we're going to go here. If the standard deviation is decreased, then this happens. So when you're let's talk basketball. Let's say you keep track of players' score, right? Scoring average. You want that player to have a small standard deviation. You want that player to be consistent. Because if a player scores like almost nothing one day and the next game a lot, and then like goes back and forth, that means that the player is not as consistent, right? Like it's harder to work with that as a coach. You can't say like your problem is you don't know what the problem is because it's so spread out, right? What's happening? So that's how you would relate this to sports. So let's go to the next page here. And soon, very soon, we're going to start doing some graph and calculator stuff that is going to be a bit more fun for you. And it's titled Using the Graph and Calculator to Find MCTs, Standard Deviation, and Range. These are the steps. I should have put that down. Steps. So you would enter your data points into L1. We all know where L1 is at this point, so that's great. You will sort your data. I will show you how to do that, but here it is to review if you forget. And then third, calculate the mean, standard deviation, and median using these buttons. And this is what you will see. You will see this on your screen. And I will show you what's what, right? This right here, if you look at the X bar, that would be our mean or average, right? This right here is our standard deviation. Look at where it's like one above the N, right? Standard deviation. And this, what does this tell us? What do you think? Number of data points. So when I did this, there were 12 numbers that I considered for this calculation. Go over to the right here. This is obviously right there. You see that? says median, just to make clear, to be clear, that is your median right there. The calculator does that all for us, so we don't have to like figure that out. And I want you to remember the min and the max, right? So the min and the max, this is the lowest value, and this is the greatest. So the min is the lowest value in the set, the max is the highest value in the set. Okay? So how would you find the range? We find the range by subtracting the max x and the min x, right, from the calculator. So there they are, right? You always take the max and subtract the min. Okay? So range is max minus min. I don't know, maybe this is something, I don't know if you need to have that on your study sheet. But in this case, it would be max is 9 minus, right? The minus comes from here, and your min happens to be negative. So it's minus negative 12. Okay? And these turn positive, of course. So it's really 21 units. What have you just found is that the difference between smallest and greatest is 21 units. We don't know what units, but it would be a 21 unit separation between the greatest and the smallest value in the set. Determine the mode or the modes by looking at L1, which is now sorted. How do you know it's sorted? It's because I sorted it up here, right? And so that will help you find the mode. So I won't show you here how it's done. You just look through it and you find it, okay? So let's try that right now. So we're gonna start by entering these numbers. Oh wait, let me just check what I did on the back side. It says calculate the mean, median, mode, and range of the daily highs. So we're gonna figure out Winnipeg and Toronto, right? They are side by side. So we're gonna figure everything out for Toronto and Winnipeg. Okay, so let's enter Toronto into L1. Let's just focus on Toronto for now. So I'm asking you to find the mean, median, mode, and all that stuff. So we're gonna go stat, edit, clear everything. Okay, and then we go 5, 5, 8, 9, 5, 0. And I'm just gonna check if I go to my last number, it says L1 12, right? So that means I have 12 entries. I'm gonna check 2, 8, 10, 12. I have 12 numbers. So once you've done that, what does step 2 tell you to do? Sort, right? You see it? So what you need to do is you press stat again. And the second option, you're so used to going into edit, go to that second option which says, what does sort A and sort D stand for? Sort A is in ascending order. Sort D is in descending order. I always use ascending order. That's what I just do. Sort A, so it's asking you which one would you like me to sort. So you go second one. Just go second one to call L1 and then hit enter and it will say done. Right, it's done. So let's go and peek. Stat, edit. You will notice that it's been arranged from smallest to greatest, which is very, very helpful for what we're doing later. So let's forget about it. Quit. Go to your home screen. This is new to you. Calculate the mean and all that. You gotta press vars. No, wait. I'm getting ahead of myself here. Sorry, guys. Not vars, right? What does it say there? It says stat, right? Stat. But you're gonna, if you want to calculate stuff, you need to go over to the right at the top. So we're gonna go over to calculate, and it's always one variable stats. We're not gonna use two variable stats. It's always one variable. Okay, hit enter. It should now be on your home screen, and now you got to give it an input. So we're gonna say go and find all the information that is in L1. So you're gonna go second one, no commas or anything, and then you hit enter. You should see this. I hope so. If you don't see this, you probably entered a value the wrong way. You might have missed it, or I may have made a mistake. Is this what you're getting? Because I'm like, okay, this is somewhat new to me, this booklet, right? So I'm kind of okay. So let's go back to page 5 and write this information down. Okay. So I'm gonna label it Toronto, and I'm gonna go. My average, my mean is 6.83 what? What are my units in? Degrees Celsius, right? And my median, watch my screen. To get the median, you need to go all the way down with the arrow until you see median right there, 7.5. Just arrow down, just like as you're looking at your screen, right? This is what you all see. And as I go down with the arrow, keep going down until median shows up. Okay? So median, the median temperature is 7.5 degrees Celsius. What's the mode? Go check it. I'm going to go to my L1. Hold on. I just want to make your lives easier. I'm going to do range right away. The range, because once I exit this, I can't get it. Then you have to redo it. So the range is going max, take away the min. So 12 minus 0. So that'll be 12 minus 0, which is 12 degrees Celsius. So the difference in temperature for Toronto is 12 degrees for the period we're considering. Now let's go ahead and find the mode. So we're going to go stat, edit, and you just scroll down, right? There I see that the 5 shows up 3 times. So that's probably it, the mode, but we're going to keep going just to check. Oh, the 9 shows up 3 times as well. So in this case, it's 5 and 9. So 5 degrees Celsius and 9 degrees Celsius. Okay. And we forgot to, I didn't ask you for standard deviation, right? Why did I not ask that? Can I do this with you here? Standard deviation. We're just gonna do this here, standard deviation like that, and just state it because I want you to start getting that as well. So I need to go back to my home screen. Oh, it's still there. Okay, I didn't know that it stays there. So I'm going back to my home screen, but I can't now go arrow up and down. Do you notice that? I can't. So I'm just gonna go second enter and run that program again. And now I can go up and down as I need to. And there's your standard deviation, 3.21. Right now it means very little to you, just write it down. It's this one right here above the N. It's 3.21 degrees Celsius. Let's do the same thing for Winnipeg. We're going to find the mean, the median, the mode, the range, and the standard deviation. Now, I got to go back to enter all that information into my... Is it okay with you if I use L2 for Winnipeg? It won't throw you off too much, will it? I just want to keep my information. So I'm going to type Winnipeg into L2. Oh, there's a negative and another negative. I guess we're in Winnipeg after all. And I'm just going to double check. It doesn't take long. But then again, I have all of you to tell me that I'm wrong, right? There we go. I have everything in L2 right now. I'm going to quickly sort it. Stat, sort, and I'm going to call L2. Now it's sorted. I'm going to slow down a little bit. I know I'm going a little bit fast here. Okay. I sorted it, right? Now I'm going to go stat, calculate, one variable statistics. I'm going to say go find everything for L2, right? I'm going to feed L2 to it, hit enter, and now I have that information that I need. So I'm going to go flip over, and my average, watch that, it's 0.5 degrees Celsius. I don't have to go in this order. I'm going to write down my standard deviation already because it's right there. I'm going to scroll down and find my median, which is right there. That's 1.5 degrees Celsius. The mode, I'll get to it in a minute, but I want to find my range first, which is 9 minus negative 12. So that's 9 plus 12, that's 21 degrees Celsius. And now I'm going to find the mode. I'm going to go stat, edit. I'm going to go to L2 and see if there's a number that is popular. There are two sixes there. That's it. So 6 degrees Celsius is my mode. Now, you ready for this? This is what I want to focus in on. What's the range for Toronto in terms of temperature? It's only 12. The range for Winnipeg, 21 degrees of separation. What do you notice about the standard deviation? If the range is smaller, you're going to have a lower standard deviation compared to the other city, right? So a lower, I will make a note here, right? Toronto has a smaller range, which leads to, we're going to go arrow, smaller standard deviation. Winnipeg has a greater range, greater standard deviation. That's what I want you to know. Would it make sense that Winnipeg has a greater standard deviation? Yes, because our temperatures go wild, right? Like we have a bigger range. It's like all over the place. We go from snow to rain to hail in one day, right? Like temperatures change a lot more than Toronto, right? If you go to Mexico, right, the standard deviation is going to be smaller. Like for the most part, it just stays like whatever the season is, it's going to stay very close to that average, right? Whatever month you're in. So I would suspect that in Mexico, the standard deviation, if I collected that information, would be even smaller, right? Because the range will be less. Okay, so what we're going to do here is we're going to create a line plot. That is new, okay? So highlight that. Or circle it. If you don't have a highlighter, circle it so it stands out when you get to it. Create a line plot for the temperatures in both cities. We always have to label the mean, median, and mode on it. Watch this. I'm going to give you some steps here. I don't think you should have this on your study sheet because it will take up too much room. But I use the min and the max to help me with my scale. I add labels and units. You place the data points on the line. Stack if there are multiple entries. That is probably important. I will show you what I mean by that. And then label location of MCTs. That is important to me. And I was kind enough to get you started there, so you don't even need a ruler for this one. But if you look at Toronto and you look at, was it negative? Oh, I'm just starting with negative 16, so they're both the same. That's all I'm doing. But I'm just going to see here, if I go up by 2s, I look at the maximum for Winnipeg, which is 9, and the maximum for Toronto is 12. So as long as I get to 12, I'm fine. Let me see here. 3. I think if I go by 2s, I should be fine. 12, 10, 8, 6, 4. No, I need to go by 3s, I think. Yeah, I'm going to go by 3. So negative 16, negative 13, negative 10, negative 7, negative 4, negative 1, 2, 5, 8, 11, and 14. So what are these? We are in degrees Celsius, so you put that down. You put an arrowhead on both ends. Okay. And we'll do the same thing for Winnipeg because I want them to both have the scale so you can see what I mean by the range and by the standard deviation, how that shows. So let's just copy this down. And we're going to add arrowheads just like before. Degrees Celsius. That's what we're in. And we're going to say that this is Toronto and this is Winnipeg, right? Even though I already have that there, but not normally when you start it from scratch, you're going to do all of that. And now we're going to place our data points along that number line. So line plot, we call that. So let's go to L1 for Toronto. Go to your lowest. This is another reason why you want it arranged. So you go through it and you put the points where they're supposed to go. 0 would be right about here. So you put an X. You can put an X or a dot on there. 3 goes right about here. And then there's 5, right? So 5 shows up 1, 2, 3 times. That's what I mean by stacking. And then there's a 7. There's an 8. There's a 9. Another 9. And another 9. You stack them. And there's a 10. A 12. And that's it, right? So for Toronto, that's what it looks like. And then we'll make a line plot for Winnipeg. So I go to L2, which is already arranged. So I got to go -12 would be right about there. -7 is right there. -5. -1. There's 0 somewhere here. There's 1 right next to it. 2. 3, and again, this doesn't have to be exactly. If you're off by a little bit, not a big deal. So 6 is stacked, then the 9 goes there, and that's it. You notice that one is flatter than the other if you just look at the graph? Toronto's is, the data is more clustered, it's compact. Winnipeg is spread out. That's standard deviation tells us that. We predicted that without doing this. Okay. Now let's label our mean, median, mode for both of them. So for Toronto, the average would be right about there. So you just point an arrow to it and just say that average is 6.83 degrees Celsius, and the median is 7.5. So 7.5 would be right about there. And my mode is 5 and 9. So it's right here, right? This is my mode. The ones that are stacked up are our modes, right? Let's do the same thing for Winnipeg. The average is 0.5, which would be somewhere in here. Do the same thing for Winnipeg. Average is 0.5 Celsius. That's X bar, sorry, not just X. And then my median, according to that, is 1.5, which would be somewhere in there. And my mode, of course, is right there. You don't have to tell me what the mode is, just point to it, and that's fine. And you can tell that, like, if you stack them up, right, the average for Winnipeg is lower, which makes sense because most points are further down, right? And Toronto's a bit higher. So now we're gonna do the describing part here. Describe the data sets for each city using the mean, range, and standard deviation. So here it is for Toronto. Mean is greater, which means it is warmer than Winnipeg, right? That's what the average would tell us. The range is smaller, which means temps, let's just do that, are more consistent. There's that word consistent. Sorry, you can't see that, right? So for Toronto, the mean is greater, which means that it is warmer than Winnipeg. The range is smaller, which means that the temperatures are consistent. The standard deviation is smaller as predicted by the range. The range already told us that the standard deviation was going to be smaller. So the range and standard deviation tell us the same thing. Let me just, for Winnipeg, I'm just going to summarize. Lower mean, that means it's colder. Higher range and standard deviation. Data is inconsistent. Or spread out, same thing. It may have more outliers, which Winnipeg, it does have an outlier. I will actually make a note of that. This would be an outlier right here. Okay, let's circle it and just say that that's an outlier. Because compared to the trend, right, there's a trend here. This one is significantly outside the trend. Okay. Unfortunately, that is reality for us, right? Hold it. So remember, this goes back to that big box that I had a couple of pages ago, where I talk about what does a lower range tell us. Tells us that the standard deviation is going to be lower as well, and so forth. So now, this is your homework for tomorrow. Just this one, it spans over to 7 as well. So 6, where everything starts here. But let me just introduce you to the problem a little bit, right? So you have two different, it's like Winnipeg and Toronto, except for you have brand X of batteries and brand Y of batteries, and that's in terms of their lifespan. So you basically want to cut this here. Some students plug in the whole thing into L1. You should put this into L1, and this is your L2, because you're comparing two different data sets. And then following the steps I just showed you, you're going to find the mean, median, standard deviation, range, and mode for both of these data sets. What does it say on the next page? Create a line plot, which we already did. And then describe the data sets, just like I did, and so forth. If you want more practice, on page 7, there's that homework, right? So pages 6 and 7 is your homework. I will go over it tomorrow, so I will not post the answer key because I want you to try it. Use pencil, do not use pen. There's a big chance that you get it wrong, okay? Because you're still fresh.